Hey guys, so I'm going to go through those practice problems with you one more time on a video so that way you have them and you can look back to. So first off, we're going to start by adding and subtracting. So when I do that, that should be something very familiar to you. You're just basically going to combine your like terms. So when I add the first function to the second function, okay, and we'll deal with this x equals -4 later. That's not part of it. So cube root of 2x plus a -11 cube root of 2x is a -10 cube root of 2x. Okay. From here, we also need to state our domain. When we have to state our domain, we're going to ask ourselves two questions. First question, did I divide? If I say yes to this question, then I'm going to set my denominator equal to 0, and that is where it cannot equal 0. Second question, do I have an even root? If I say yes to that question, I set the radicand equal to 0, greater than or equal to 0, and I solve that because no even root can be negative. I have to make sure it's always positive. So in this case, I did not divide, I added, and I have an odd root, 3. So it's no to both of those questions. So this domain is simply all real numbers. We like those. There's no restrictions on it whatsoever because I did not do one of these two things. So if I then subtract f minus g, same thing, I'm subtracting the same two functions from each other. Just be careful with your subtraction. Very common mistake is people forget to distribute that minus sign. I forgot mine here. There we go. They forget to distribute, which changes it to a positive 11. And now when I combine my like terms, I have 12 cube root of 2x. I'm going to ask myself the same two questions. I already know the answers. I did not divide, and I still don't have an even root. Nothing changed in the process here. So again, in this case, my domain is all real numbers. Now, the last part is simply substituting. So if I ask you to evaluate at a certain x value, you would simply plug it into your solution and get some value, some number. I'm not going to spend time going through that on this video. We know how to substitute and use a calculator for that. But that is what these last x equals are asking us to do. Okay. Number 5, same thing. I'm going to start by adding my functions. You got to be careful with these because they may not give it to you in standard form as you see here. It is not. Just make sure you put your answer in standard form in the end. So when you go through combined your like terms, we're going to get -7x cubed plus 5x squared plus x as my addition. For my domain, again, I'm going to ask myself the same two questions. Did I divide? Nope, I added. Do I have any even roots? No, there's no roots at all. These are all nice whole number polynomials. So again, in this case, I have all real numbers as my domain. Second one, I'm then going to subtract. Move myself up here. And again, make sure when you're doing your subtraction, you are distributing that. So we get a -9x squared and a positive 5x now from when I go through and combine my like terms. So in this case, I have a -7x cubed minus 13x squared plus 11x. Again, ask myself, did I divide? Nope, I subtracted. Do I have any even roots? Nope, nice polynomial. So again, I have all real numbers as my domain. Okay, so let's move on to multiplying and dividing. Leave myself up there. All right, so again, with multiplication and division, we're going to evaluate. Actually, we're not going to evaluate, but I could ask you to evaluate. And we also need to provide domain restrictions or any domain restrictions that we might have. When I look at these, again, I'm going to start by multiplying first. When you do problems with our rational exponents, you're just going to simply apply your exponent rules. But before I start that, I want to take note of, well, what do those exponents actually mean? So a 3/2 actually means this is 7 square root of x cubed. Again, we don't tend to put the square in there, but I do have a square root of x cubed. And this one over here, x to the 1/3, means it's negative 14x cube root of x to the first. I want to be aware of those roots because remember, I'm asking myself two questions. I'm asking myself, did I divide? And then I'm going to ask myself, do I have an even root? So I need to be aware of what those exponents mean so I can answer that question. So anyway, when I do my multiplication here, multiply your numbers, you get negative 98, x 3/2 and 1/3. So you got to add those, right? 3/2 plus 1/3. I need to get common denominators. So this would be 9/6 plus 2/6. That's 11/6. And that would be my solution. So that's my multiplication. I got negative 98x to the 11/6. Again, I want to keep in mind, well, what does that actually mean? That means it came from here. You do not have to simplify it. You do not have to rewrite it. In fact, they gave it to you in exponents. You want to keep your answer in exponents. But now I'm going to ask myself those two questions. Did I divide? No, I multiplied. Do I have an even root? Yes, I do. I had one up here, and now I have one in the answer. So I have to look at both of those. Okay, so my domain restriction comes from my even roots. You are going to set the radicand, that's the inside, greater than or equal to 0, and then solve. So I got two radicands I have to look at because I have two different even roots. I have the even root I started with, and I have the even root I ended with. I need to make sure they're on the same page with my domains. So the radicand of the first one is x cubed. So x cubed greater than or equal to 0. And I would solve that. You would cube root both sides. Well, the cube root of 0 is still 0. So this is x is greater than or equal to 0. That's the first one. Second one is the 6th root of x to the 11th. So I'm going to take the inside of it. Actually, I don't even need the 6th root part here. I just need the interior of it. So just this x to the 11th. Set it greater than or equal to 0 and solve it. Still going to be 0 because, in case you don't know, you're taking the 11th root to get rid of the 11th power. Still, any root of 0 is still 0. So since these are the same, I don't have to worry about anything. I know my domain. My domain is going to be x has to be greater than or equal to 0. Because that's what I got here. Those were my restrictions. Radicand has to be greater than or equal to 0. Those were the values, so I can leave it as is. Okay, I'm going to scroll down so I have space here. Now I'm going to look at dividing them. So again, with our dividing fractions, or functions, we're going to leave them in the fraction form. Obviously reduce what we can. So in this case, I do want to use my exponent rules. So you divide the numbers, which comes out to 1/2 or a negative 1/2. And then you're going to subtract your exponents, and it's not 4/3, it's 1/3. There we go. So now 3/2 minus 1/3 gets you x to the 7/6 power. And it goes on top because 3/2 is my bigger one. So this is my reduced fraction, my simplified division. So now when I go through my domain, I got two problems here. I have the domain restriction of division. And I have the domain restriction of the even root. Because this original even root didn't go away, it's still going to be there when I divide. So let's talk about our division. With the division, you are going to set your divisor equal, actually not to equal 0, because we want to know where it's not going to be 0. So our divisor in this problem is our denominator. So negative 14x to the 1/3 cannot equal 0. I'm going to solve it like I normally do. You're going to divide by the negative 14. Still going to be 0. And now in this case, you might not know it yet. We will get to it eventually. But a trick, a little shortcut to get rid of your powers here, the 1/3, is you just raise it to its reciprocal. So 1/3, I'm going to raise it to 3/1. They will undo each other. And 0 still to any power is 0. So x cannot equal 0. It's first thing. Second, my even roots. I already did them, but I'll go through them again. So I had the square root of x cubed. Solve it. I know x has to be greater than or equal to 0. That was this one here. Now I take the solution, x to the 7/6. Remember that would be the 6th root of x to the 7th. Set that greater than or equal to 0. Still going to be greater than or equal to 0. But I got to look at 3 things now. I have to look at these 2, which I already know are greater than or equal to 0. And I got to bring this one into play also. Well, these 2 have to be greater than or equal to 0. And the division one is telling me it can't equal 0. So that tells me when I have to write my domain out, my domain restriction, I can't include the or equal to because of this part right here that says it can't equal 0. So this is where it gets a little tricky. When I have multiple domain restrictions, I have to figure out, well, how do I make that work? How do I make that make sense? But if one tells me it can't be 0, and another one says it has to be greater than or equal to 0, but I can equal to 0 because of the dividing, I'm not going to put the or equal to sign now because that will guarantee that it will never equal 0, but it will also be positive, so it will work in all of my even roots. All right, so let's try one more with our dividing and our multiplying. So again, if I take a look at these 2, put a line down here, and start by multiplying. Now, again, I'm going to try and keep in mind what do these actually represent. So this actually represents the 4th root of x to the 5th. And this one here represents 2 square root of x. So actually I have 2 even roots here I'm looking at. When I multiply those out, I'm going to get 8x. Again, I'm going to need to add those exponents together. So 5/4 plus 1/2, which is 2/4, is 7/4. And again, that will be my multiplication. And if I needed to keep in mind, this is actually the 4th root of x to the 7th. Got a lot of even roots here. I have one over here with the 5/4. I got one over here with the 1/2. And I got one over here with the x to the 7th. Now, as you get good at this, and you notice if they're all just x's on the inside, no matter what their power is, that still always going to be greater than or equal to 0. But if you want to go through them all, we can. And just for your own, x to the 5th greater than or equal to 0, well, that's still going to be x is greater than or equal to 0, no matter what I root it. 2 squared of x, well, x is greater than or equal to 0, done. And then the one over here, 4th root of x to the 7th, x to the 7th has to be greater than or equal to 0, still greater than or equal to 0. So since all 3 of those did come out to be identical, I know my domain has to be x is greater than or equal to 0. Okay, now our division. So again, I'm going to set up my fraction. I'm going to divide them. So when I divide, 4 divided by 2 is 2. 5/4 minus 1/2. So again, I'm going to subtract them at this point. So 5/4 minus 2/4 is 3/4. And that would be my solution. Again, if I want to keep in mind, that is the 4th root of x cubed. So here's our big one. We got a bunch of domain restrictions here. I have the division, and I have the even roots. Again, I can go through all of the work that I did up here, but I know they're not changing. X to the 5th, the x from the square root of x, even my cube root of my x of the 4th root of it, still not going to change. So I know right away, without even doing much work, I know this is going to be my even root issue. Please don't always assume that, because I could give you a radical that has x plus 1 inside of it or something to that effect. Okay, so you may still have to do some work, but if it's just a single variable, if it's just x to any power, it's going to be x is greater than or equal to 0. Okay, our division one, though, we're going to take our divisor, what we divided by, so this one here, 2x to the 1/2. I'm going to set it to not equal 0, solve it, divide by 2. I'm going to raise this to the 2/1 power, because again, if I raise anything to the reciprocal power, it'll undo itself. But 0 to any power is simply 0. So x cannot equal 0. And again, if I look over here, x cannot be less than, so it has to be greater than or equal to 0. And again, since I'm saying I can't have it equal 0, my domain is simply x is greater than 0. You just would not include the or equal to there because it cannot equal it due to my division issue. Okay, so that's our domain for those two questions. And again, we're going to be practicing more of those in the next day or two. The final thing is compositions. So when you see this open circle, that's your composite. All it means is you're going to put one function inside the other. So h is going to go inside g. In this case, h is going to go inside itself because it's h of h. So when I go and write this, so the function of g, or the composite of g of h of n, h is this function. I'm going to simply substitute it in. It's just like doing the substitution method. Instead of finding an actual solution, we're just simplifying a polynomial inside another polynomial. So again, you can see I substituted it in. I would just distribute. And if I could combine any like terms, I would. But that is my composite. I'm still going to talk about domains. Did I divide? Nope. Plugged one into the other. Do I have any even roots? Nope. It's a polynomial, all whole numbers. So my domain is all real numbers here. Okay, and the last one is h inside h, and then with a -7 on the inside. So if I want to kind of show you, I'm taking this and then plugging it into here. Looks crazy, but it's not as bad as you look. And then we're going to deal with the -7 last. But if I do with the letters first, so -2 of itself in where the x was, and then I distribute, combine like terms, I get this. And now this -7 on the inside, so h of -7 just means you're simply going to substitute a -7 inside your final answer. And then whatever you get when you calculate that, which ends up being -37. So that's an evaluation function looking notation. And again, if I go back, because I didn't talk about it before I substituted in, my domain is all real numbers. I didn't divide, and I have no roots. So hopefully these examples gone through yet again, watching it another time helps you out.